Okay, so we talked a little bit about pathways yesterday. The basic ones where you're going from one corner to another. So you look at the dimensions. You're not counting the street corners. You're counting the blocks. So 1, 2, 3. 1, 2, 3. Right? So that number of pathways is going to be the total of these two dimensions. 3 plus 3 is 6 factorial. And then you divide by the factorial of each dimension. Okay? And you can figure out what that is. Actually, you can do it in your head, because think about it. 6 factorial divided by 3 factorial will be 6 times 5 times 4. 3 factorial is 6. So you're left with 5 times 4, which is 20. Okay, start getting that mental math going. You have a month and a bit for calculus. Okay? So, this one's the same. I'm going to leave it. This one, if you're going from A to B, well, how many ways? 1. Because you have to always move closer. So that's just going to be 1. No real math to that one. Okay. So I went through 4 and 5. Give you a little hint on that, remember? So 4 and 5, you have to go through C first. So that means you can't go into this area, because then you would have to come back to C. So we do the number of ways to get from A to C, which, I mean, you can count them up in that sense, but it's the dimensions of 1 and 2. So total is 3 factorial over 1 factorial, 2 factorial. So it's just 3. For each of those 3 roots, there's 10 roots here. So 3 times 10 is 30. Okay, you don't add them, you multiply them. So this one here, have to get from A to C. So really, we don't care about those parts to it. This is 2 and 2, so that's going to be 4 factorial over 2 factorial, 2 factorial. Again, in your head, 4 factorial divided by 2 factorial is 4 times 3. 4 times 3 is 12, divided by 2 is 6. Here, that's going to be 10. We've done that one many times now. 3 by 2. Okay. So then the number of pathways will equal 6 times 10, which is 60. Okay. So for each of the first rectangle, you have all of the other pathways, so you multiply them together. Okay, then this one, you have to go to C first. Well, there's only one way to get there. And then from C to B, there's 3 ways. So 1 times 3 is 3. In order to go from A to B in this one, you have to go to this corner. So it's not labeled C, but it's like having C there. There is no choice. You can't, there's nothing there, no street corners. So you find for each rectangle, so that one is 4 factorial over 2 factorial, 2 factorial, which we did over there. This one is the same, 5 factorial over 2 factorial, 3 factorial, which is 10. And this one's the same as the other one we did. 3 factorial, 1 factorial, 2 factorial, equals 3. So for all 6 of those, there's 10 of those. For all 60, there's 3 of this. So it's going to be 6 times 10 times 3. Okay, so So the next one gave you a little hint. Obviously, you have to go through B. It says that in the question. So that's the same 3 by 2, right? So there's 10 ways to get from the mall to B, okay? Problem is here, this isn't a rectangle, okay? So I'm going to label that as 10, kind of like I did it the long way when we first learned about these. So there's 10 ways to get to B. To get to the airport, obviously I can't go there. I'm not going through the lake. I'm not going for a swim. So here at 10, we have to do it by hand to get to the airport. So go to each street corner from 10. So to get here, there's 10 ways to get to the previous. So there's still 10 ways to get here. Okay, because you can't come from the right. To go down here, still 10 ways. Okay? Because again, you can't come from the right. So if it takes 10 ways to get there, it's still 10 ways to get here. Okay? This point over here, 10 to get there, the only way you can get here is from the left, so that's 10 as well. Because you can't come from below or from the right. Okay? Now, to get to this street corner, you have to look to the left. You can come from the left, there's 10 there. You can come from above, there's 10 there. So in total, there's 20 ways to get to that street corner. Okay? So you're adding the previous diagonals. So then to get to this street corner, you have to either come from the left, so there's 10 ways to get to that point, or come from above, there's 20 ways to get there. So in total, there's 30 ways to get to that street corner. You add the previous diagonals. Okay, so now what do we do? So this street corner here, from the left, 20 ways. No, nothing from above, because there isn't a road there. And you certainly can't come from the right or below. So this is going to stay at 20. There's only one route in to that. Okay. So then this corner, there's 30 ways to get there, 20 from above, so in total 50 ways to get to that point. Now, this corner here, I can get there from the left, 20 ways, or from this diagonal. Because from this corner to this, you're still getting closer to the airport. So there's 10 from there, 20 from there, is 30 in total at that point. Okay, and then this corner, either from the left or above, that's 80. So now, that's your final answer. You don't multiply anything because you incorporated that 10 to start. From there, there was 10 ways to get there, and then we found the number of ways from that. So anytime you have a rectangle, you're taking the previous diagonals. If you don't have a rectangle, you're taking the previous line segment where it ends up in the vertex. Okay, so 10 and 20 is the. So, next one is the slot machine. What is the total number of paths the ball can take to reach the bottom? Okay, so if it's a random case, think about, so there's the ball or the marble that's going along the white parts. These are solid, right? And then it's going to come out one of these slots, all right? So if we think about here, this marble coming down, and if we look at each of sort of the vertices of the triangles where they get to this open spot, how many ways to get there, then we'll go to the open spots at the end. So here, there's just one way to get to the top of the actual triangle, right? That's a little bit above, one way to get down. Then from there, to get to this point, there's only one way there. Because the pinball is not ever going to go horizontally, okay, or back up. So in this particular pinball machine, or whatever you slot, well, it's a pinball, I guess, it is always going to move down, or diagonally down. So here, one way to get down here, just one way, here, one way, here, one way. There's only one way you can get to slot 1, by going down the edge. Same on the right, only one way to get to slot 5. It will not go down and then across. Okay? Gravity will. Okay, so then to get to this open space here, there's one way from the top left, one way from the top right, so there's 2 ways to get to that. The next opening here, before it has to switch directions, how to get here, one way from the top left, 2 ways from the top right, so in total 3 ways to get there. Same in this one, 2 ways, 1 way is 3 ways. And then to slot 2, 1 plus 3 is 4. You can either go down and around there, or 3 ways to get here and down. This would have 6. This would have 4, and we have the 1. So the total number of paths, in this case, will be 1 plus 4 plus 6 plus 4 plus 1. Which is 16. Just some interesting stuff. We'll talk next week about it. So that total number is 16. If we cut this slot machine shorter, 1 plus 3 plus 3 plus 1, that's 8. If we cut it even shorter, 1 plus 2 plus 1 is 4. Even shorter, 1 plus 1 is 2. So the total is 1 here, 2 here, 4 here, 8 here, 16 here. If we extended it, what would be the total slots? 32. If we extended it more, 64, and so on. Those numbers form what's called the Pascal's triangle. Okay, so you may have heard of Pascal's triangle. You've heard of Pascal. Okay, Pascal did a lot of stuff, and triangle, the pattern in that is named that. You've never heard of Pascal? No. Science? No.
Wasn't your art?
There's a computer programming language called Pascal. There is, isn't there, when you're doing temperature, volume, pressure? Oh my God.
Wasn't Pascal an artist?
Probably as well.
You know how like the test, like the Gauss method?
Yeah.
In grade 9 I thought this was
Okay, so that's just a little heads up for next week. Take a look, you'll see something similar from here. So this is a checkerboard. We've got a checkerboard piece on a white square, and it says how many ways can the black checkerboard piece make it to the other side of the board. It must always move forward and stay on the white square. So we're never going on the black squares. So that means we could never get it over here, because we always have to be moving closer. So basically, you're cutting off that, and you're cutting off this, okay? And you have to move only on white squares. So there's only one way to get to that square, only one way to get to that, and get to that square, okay? Then these, only one way, one way, one way, one way. So you form a triangle from it. Now, there's more to it afterwards because the triangle is kind of cut off by this board. But then this white square here, there's one way to get to the previous line on either side. So there's two ways to get there. If you think about moving your checkerboard piece. Then here, one way plus two ways is three ways. 2 plus 1 is 3. 1 way plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Okay, but notice how the triangle's cut off. So we don't have a 1 on the left here because it would extend out. Okay, so then here, 4 plus 6 is 10. Now to get here, you have to come from this part, right? Because it's cut off there. We can't come any other way, so that would stay as a 4. 6 plus 4 is 10. 4 plus 1 is 5. 4 plus 10 is 14. 10 plus 10 is 20. 10 plus 5 is 15. Again, this would have to stay as a 5. This would have to stay as a 14. 14 plus 20 is 34. 35. 20. Okay.
The total would be 103.
Is it? Yeah.
It doesn't look like. Well, it's because like that's about 70 plus 20 plus about 35.
Okay, so then there's lots of practice questions. So your timeline,